Right, this is circular functions on page 315, section 21.3 of the higher course. Now, before we get on to plotting graphs and seeing their characteristic shapes and what have you, I want to give you some background information which isn't taught in the current new course but was taught under the old scheme, but it does give good insight into why graphs have a particular shape and why the graph of y equals sine x has a particular shape and why the graph of y equals cos x has a particular shape. Now, you've been used to working with angles in triangles or angles on straight lines or angles in any sort of shape there. We've tended to work, certainly with trigonometry so far, with angles that are below 90 degrees, but of course angles can go above 90 degrees, say 106 or 120. And if we have an angle of 120, therefore, does it have a sine and a cosine and a tangent? Well, the answer is yes, it does. But all the angles are related to their sine, cos and tan in the first quadrant. Let me show what I mean by quadrant. Let's make a start here then. Right, this is not a pair of axes. Alright, it is not a pair of axes. Looks like it, but trust me, it's not. Imagine, if you would, well, let me tell you what it is first of all. Make it a little bit thicker. If this is 0 degrees, then if you go anti-clockwise in the positive direction, that's 90 degrees. If you go anti-clockwise again, we're now on 180 degrees. And carry on going anti-clockwise, it's to 70 degrees. If you go back home again, we're up to 360. Alright, so for example, if I've got an angle like this, and I'm calling that 30 degrees, again I'm just using this as examples. Let's go black, see how it looks. If that is 30 degrees right there, then if I was to continue the line straight through as follows, I'd get another 30 degree angle there, wouldn't I? So 30, 30. Let's face it, they're vertically opposite angles. But look, if I'm starting reading from here along the 0 degree line and go anti-clockwise, look, 90 plus 90 is 180 plus the extra 30 is 210 degrees. So the angle I'm looking at now in the third quadrant, 1, 2, 3, 4, is this angle here. So that angle is going to be all the way around there, anti-clockwise direction, and that will be 180 plus the 30, which is 210 degrees. Alright? So an angle of 210 degrees is actually related to the 30 degree angle there. Now, what if I have a pair of lines like this, and I'm going to go for 30 is in the other direction now. So essentially this will be 30 degrees as well. Again, it's obviously bigger than the one I've drawn, but again, it's just a demonstration. If that's 30 degrees and that is also 30 degrees, then this angle will also be 30 degrees because it's vertically opposite the angle I'm trying to highlight there. So let's look at it carefully then. If this is also 30 degrees, then the true angle when working in the anti-clockwise direction is this one, all the way around, 180 plus 270 plus, not 360, but it's going to be 360 less than 30 degrees. So this is essentially 330 degrees in the fourth quadrant. So here's the first quadrant, here's the second quadrant. Again, this is all background knowledge. This is the third quadrant, and here the fourth quadrant. Okay, so first, second, third, fourth region. So even the angle of 330 degrees is related somehow to the angle of 30 degrees. So if I was to go this way around in the clockwise direction, that will be called minus 30 degrees, and minus 30 degrees is exactly the same as a positive 330 degrees going anti-clockwise. Now, what about in this second quadrant here? Well, if that's 30 degrees and that little snippet there is 30 degrees, then the true angle is that one, going anti-clockwise again. So we're looking at 180 degrees, take away that little snippet of 30, so we have 150 degrees in the second quadrant. So, quick review. We've got 4 angles, one in each quadrant, all of them related to 30 degrees. This one, 150, is basically 180 degrees minus that 30. This one here, the 210, is basically 180 plus the 30. This 330 degree angle all the way around here is basically 360 minus the 30. So you can see it's related to 30 degrees. Now, let's just do some sine, cos and tan. Well, in fact, in the new course you don't need to know about tan, but we used to do it even up to last year. So, last year being 2011, of course. the last time the old spec was running. So we're just going to work with sine, cos and tan. Sine and cos only. Now I've got my calculator to go. Now working with sine and cos only, if we're based with sine 30, everything's based on the 30 now. If I press what sine 30 is, I know it's 0.5 because I just remember that from school myself. So if you check on your calculator, go sin 30 equals, you get 0.5. Not very interesting, is it? Now 150, what about sine 150? So I'm going to go sin 150 equals, it's still 0.5. It's incredible. If you can see that, right, the sine of 150 degrees is 0.5. So let's just write it down in the second quadrant. Now surely that gives you a little hint that the 150 is in fact related to the 30. They have exactly the same sign. Not surprising, because if that little bit is 30 there and that little bit is 30 there, well, between them they sort of make 150. If you go all the way around to 180, take off the 30, 150, so it's believable that the 30 degree angle and the 150 degree angle are related. Now what about this little snippet here? Well, that's 180 plus the, 180 plus the 30, 210. So let's see what the sine of 210 degrees is. Okay, so I'm going to go sin 210. I've got minus 0.5. Don't know if you can see that. That's what we've got. And finally, the last one, we go for the sine of 330 degrees, which is better. Get a bit better. Sine of 330 degrees, which is basically the sine of minus 30 degrees. Let's see what we get then. So sine of 330 equals, and I don't know if you can see that, the sine of 330 degrees is minus 0.5. So what have we got? We've got 0.5s all the way around the clock, so to speak. So it's going to be positive or negative. Alright? Now, so I want you to see at the moment, here the sine has a positive value. So I put just a positive there. So sine is positive there. Here in the second quadrant, sine is positive there. In the third quadrant, sine is negative. And in the fourth quadrant, the sine is negative as well. So we go positive, positive, minus, minus. So the sine of 30 is positive. The sine of 150 equals the sine of 30, which is positive. The sine of 210 is equal to minus the sine of 30, in other words minus 0.5. And the sine of 330 is also equal to minus the sine of 30 degrees. Alright? So here we are working in 4 quadrants with angles from 0 to 360 degrees. We can of course go clockwise and work with angles from 0 to minus 360, going all the way around here in the negative clockwise direction. So here we go. We're playing with sines with angles above 30. Above 90 degrees into the second, third and fourth quadrants. So we're looking at sines for angles up to 360 and minus 360 if we choose to go the other way. Now I'm going to carry on and do the same thing for cosine, see what we get. So if I plant my cosine work over here, hopefully, let's just start a fresh page, stick it right in the middle. Right, great big one of these. We're going to work with cosine. Same again, we'll play with 30s, do that, and try and make it look half decent as well, and we'll do that. So let's just label up. We've got 0 degrees, we've got 90 degrees, remember these are not axes, we've got 180 degrees there, we've got 270 there, straight down, and we've got 360 going back round in the anti-clockwise or positive direction. Let's carry on playing with 30s. So that's 30 degrees there, and this one's going to be, well, it's going to be 180, take away the 30, so that's 150 degrees, and this one all the way around to there, it's going to be 180 plus the 30, because these are vertically opposite, so that's going to be 210 degrees, and the last one's all the way around to there, but not quite back to the beginning, so that's going to be 330 degrees, just like before. Alright, have a quick comparison. Turning left, there it is, up in the corner there, 30, 150, 210, 330, and that's what we've got on this side as well. Okay, so I've just spread it out a little bit more. Alright, let's just play with cosines then. what is the cosine of 30 degrees? Well, I seem to remember this one again from school. I think it's 0.866. So cos 30 equals 0.866 plus some other bits of rubbish as well. I'm happy with 0.866 for demonstration purposes. So 0.866 is the cosine of angle 30. And let's just do the cosine of angle 150. Let's just do that now. So cos 150, guess what? Minus 0.866. And what about the cosine of 210 degrees? Do it now. So cos 210, doink, minus 0.866. Can you see it? Just believe me anyway. If you can't see it. Oh. So minus 0.866. And what about 330? Well, the cosine of 330, doink, positive 0.866. So let's write it in there. The cosine of 330 is going to be positive 0.866 and not negative. Okay, let's stay now. So what have we got then? We have got, obviously cosine is positive in the first quadrant. In the second quadrant it's negative. In the third quadrant it's negative. And in the fourth quadrant it's positive. So when we've got angles from 0 to 360, all the cosines are positive in the first quadrant up to 90. And in the fourth quadrant from 270 to 360 they're also positive. Now contrast that with the sine. The sine was positive in the first and second quadrant. There it is there with the 150s and the 30s. And here with cosine we have positive cosines in the first quadrant and the last quadrant, the fourth quadrant there. And so let me just stop the video now. We'll be looking at real graphs of sine and cos in the future videos, and we'll see how we can use them to solve simple equations, but using the shape of the graph and also our knowledge of where sine and cosine are positive in each of the four quadrants. Alright, so I'm going to stop there, get that into your head, and I'll catch you quite soon with a live video of the graphs themselves. So see you soon.